is just an additional method using a Laplace transform, where you still need to utilize the initial condition. So this is the question that we have the sequence of events. So we have sequence of event. For example, you have event 1, then after event 1, continue with event 2. So you need to sketch the level response for a tank with a constant cross-sectional area of 4 and a function of time undergoing the flowing sequence of event. So initially, at time equals to 0, the initial steady state value is 1 foot with the drain open, and that level and outflow rate are linearly related. So meaning that if we are using the outflow symbol as Q0, so this is the outflow, it is linearly related to the level, for example, like this. So if you have a tank, so you are having your Q0 as the exit volumetric flow rate, and then this is your level. So in this sentence, when drain open, so when this is the drain open, the Q0 is linearly proportional to the H. So if you want to make it a linear equation, then you'll be having the equation of C multiplied with the H. C is the constant. So you need to solve this constant C later. And then the steady state inflow means you have the Qi, and outflow are initially equal to 2 cubic feet per minute. So you have the QIS, QOS equals to 2 out of 3 over minute. So this is the information given to you at the beginning. The steady state inflow, QI. So this is the inflow. This is the outflow. You are having QIS equals to QOS, steady state. Or you prefer to write QI bar equals to QO bar equals to 2 cubic feet per minute. The graph should show key numerical values, which means you should show the change of the level versus the time from the beginning. T equals to 0. Then for the event A and event B, event 1 and event 2, you have to show the key numerical values. Means, for example, if let's say this is the one going up, you have to show what is this value, then going down, then what is this value, something like this. So you need to show all the important values over here, and then so you'll be having event A, event B, something like that, key numerical values. The values will be always like the initial value and the steady state value, for example. So they are the significant key numerical values. And then, for example, the endpoint of this one, let's say this is T and then 3 minutes. So event B, the initial, you should not. So for event B, for example, the second event, for example, you have to start from T minus 3. So you cannot write for event B, the initial condition is H as a bracket of 0. No, because the event B starts, for example, in this question, after 3. So the unit they are using, it is minute. So after 3 minutes. So for event B, the initial condition should be H and then bracket T minus 3. So T minus 3 meaning that T equals to 3, event B starts. So if you put T equals to 0 means you put like this, for event B is wrong. Because the event B starts when time equals to 3 minutes. Okay, so we'll briefly go through this question 1 together. Okay, the full solution you may refer to the solution later. So I will briefly go through this. Okay, so I already opened the together mode. So the one joining, please on your webcam so we can see everyone here. So abstract information is very important. The area is given. So at time equals to 0, it is given as 1 foot. Okay, and then your Q0, when drain open, it is linearly proportional to the H. So Q0, it is CH. So when we change to equation, so this is the outflow. So you may sketch a bit. So this is a one inflow. This is Q0 outflow. Okay, and change to linear equation, it becomes C multiplied with the level in the tank. So this is when drain open. Okay, the flow rate will be proportional to the level in the tank. The higher the level in the tank, the faster the Q0 or the bigger value. And then you'll be having this sentence initially equal to 2 for the inflow and outflow. So at T equals to 0, your initial value for the QI and also the QO equivalent to 2. Okay, show supporting calculation using steady state and dynamic equation below. Hint, you cannot do the calculation for each part as if starting from T equal to 0. For example, your event B actually start from 3 to 33. So the initial condition for event B should be T minus 3, not T minus 0. This one is 0, initial condition, because it starts from time equals to 0 until time equals to 3 minutes for event A. So it is the event in sequence. For example, we start to solve the A. So the drain is suddenly closed. So meaning that your Q0 equals to 0. When this drain is closed, then you won't be having any outflow. Your outflow will be Q0 equals to 0. Okay, the inflow, okay, the inflow remain the same for the same value, which is 2 feet out of 3 per minute from the time from 0 to 3. So they want you to sketch H as a function of time versus the time. Means the level change. The level change versus time. So now you have to check. We have only 3 conservation law where we have the mass balance. So for whatever conditions given, you should always start the mass balance. And then we do not have composition. We do not have energy balance. So from here, we are having dm over dt equivalent to mass rate in minus mass rate out. So we have derived this many times already. So you'll be having this. You do the expansion, then you're having rho AH. So rho and A both constant. So the accumulation term will be dH over dt. So then density multiplied with the volumetric flow rate will give you the mass rate. So your mass rate is density multiplied with the volumetric flow rate. Then you only have one in and one out, rho Q0, where your Q0 is CH. So in this case, for the A, they say the drain is suddenly closed. So the drain is suddenly closed. It means you're having your Q0 equals to 0. So therefore, this term becomes 0. Okay, cancel the density. A dH over dt equivalent to Qi. And from this event occur covering the time from 0 to 3, and your Qi is remain constant with the value of 2 cubic feet per minute. Means this value is constant. So you can highlight this. So this Qi is a constant. Means if I sub the equation with the value, if I sub the value in this equation, is 2. It is a number. So it's a number. Is a number. Okay, then you can Laplace transform both sides. Laplace transform both sides. You'll be getting as hs minus h0. So this is not transfer function example. That's why I say it's an additional question using a Laplace transform. So this is not using transfer function method. It is using the Laplace transform, where you need initial condition. You need initial conditions to solve this question. It is not transfer function. Transfer function means you are going to use the unsteady state balance minus steady state balance. That one is transfer function method, but this is not. You will need the initial condition to solve, where the initial condition is given as when time equals to 0, this is the initial condition, 1 foot. So this is equivalent to 1 foot, equals to the Laplace transform of 2 will give you 2 over the s. Okay, so from here, sub in all the value, you'll be having the a is given as 4. So you have 4a and 4s, then hs minus 1 equals to 2 over the s. Okay, so rearrange to get your hs equals to so you were actually having 2 over 4. The s is inside. Okay. So a is constant. So here, like this one cancel. Okay, so you'll be having shs equivalent to 2 over 4, and then plus, so remove that plus 1. So I'll do it here. So we'll be having hs equivalent to 2 over 4s plus 1 over the s. So split into 2, we'll be having 2 over 4s multiplied by 1 over the s plus 1 over the s. So it will be 1 over 2s squared plus 1 over the s, hs. Then refer to the Laplace table, you will get this equivalent to 1 over s squared. It's a direct conversion. So let me open up my Laplace transform. This one. So 1 over s squared. So 1 over s squared is this one. The answer is t. So it's term number 3. Then you'll be having 1 over 2 t plus 1. Okay, so this is your solution, the equation to represent the change of level versus the time. Okay, now you need to sketch this for the time from 0 to 3. So this is something like, I will draw at the back, the next page, but the idea is you should having this equation. Okay, let me move this one to the next page. So you need to sketch this solution equation on the graph. So you'll be having this when t equals to 0, h0 will be 1 over 2, 0 plus 1. So the initial is 1. So 1. This is h, this is time. Then this is a straight line. So in order to form a line, straight line, you only need 2 dots. So I will take the initial and also the end point of this event, which is from 0 to 3. So 3. So I will have h3 equals to 1 over 2, 3 plus 1. So 1.5 plus 1, 2.5. So this equation sub into here for t equals to 0 and t equals to 3. To get the 2 dots, then you can join them together. Okay, so from here, you will be having the second point is here, 2.5. From time equal to 0 to 3. Example, so here. So it's a straight line. Done. So this is event A. Now continue with event B. It's okay, I just solve the whole for you. We have time? I think we have time because I need to spend more time on the heavy side. Okay, so I will move on. Okay, the speed will be faster a bit. So this is event A. So for event B, the drain is open for 30 minutes. Okay, meaning that it is actually start from 3, then plus 30. So 3 plus 30, it will be 3 to 33 because this event starts at t equals to 3 and lasts for 30 minutes, so 33. So 3 to 33. While keeping the inflow, again, it is a number, so it is a Qi equals to 2. It's a number, constant. Where a steady state is essentially reached, so they want you to sketch this. So extract information from there, you'll be having event B. Your Qi, it is still constant, and the value it is 2 cubic feet per minute. And now it is drain open, meaning that you'll be having this Q0 equivalent to CH. And you can copy the information just now from the question. During steady state, this value, 2 cubic feet per minute, is given. Okay, so this is drain open. You will be getting this equation. Okay, and the event lasts from time equals to 3 and finish at time equals to 33. Okay, so now to solve the C, you have Q0 equals to CH. So if this is the equation, Q0 equals to CH, it is valid. You can use this equation during unsteady state and steady state. So we can use this for both steady state and unsteady state. So this equation changed to steady state. Means initial condition. HS is initial condition. So this one is given when t equals to 0, according to the question. So at time equals to 0, the Qi and the Q0, they are the same value, and it is 2 cubic feet per minute. So this is at time equals to 0. So at time equals to 0, so corresponding to H0 equivalent to 1 foot given the question. So this one given. At time equals to 0, Qi, Q0 equal to 2, and the level during that time equals to 0, it is 1 foot. So this will give you 1 foot. So from here, your Q0 is 2. C, do know, but you know this value is 1. So your C finally will be 2. Then if you include the unit, the Q0 unit is feet power to 3 over the minute. Then your HS is in feet. So you'll be having C equivalent to this multiplied with 1 over this one. And finally, you will get the answer of 2 feet power to 2 over the minute. So this is your C. So you already solved your C. Then you can substitute the C in your mass balance. Okay, so your mass balance. So now we are going to write the mass balance. dm over dt, so event B from time equal to 0 to 33, rho qi minus rho q naught, rho a dh over dt. So from here, cancel the rho, you'll be having a dh over the dt equivalent to qi minus q naught equals to ch equals to 2h. So we're having rho cancel first, then q naught equals to ch, and c equals to 2. So finally, you will get 2h. So 2h. Okay, so from here, constant. So qi equals to 2. So from here, you'll be having a dh. So you can actually sub the a as well. A is 4. So I have 4. A equals to 4. dh over dt equivalent to 2 minus 2h. You Laplace transform both sides, you'll be having 4shs minus h0 equals to 2 over the s minus 2hs. And this one, you should replace with h t minus 3 because event B starts at t equals to 3 minutes. So you have 4shs minus h t minus 3 equals to 2 over s minus 2hs. And initial condition, which is the h of event B, actually is the endpoint of this one. So here is h t minus 3 equivalent to 2.5 feet. Initial level for event B is 2.5. Here, 2.5. So the endpoint of event A will be the starting point of event B. So 2.5. So 2.5 feet. Then you sub everything in. You'll be getting the HS. You move to the left hand side. Okay, so we continue. So you'll be having 4shs. Just now the last line I copy again. Plus 2hs. So you move the hs to one side, then 2 over the s plus 4. So you do the expansion. Means you do this expansion. Multiply inside, multiply inside. And this is 2.5. So that's why you have 4 multiplied with 2.5. So 4 multiplied with this minus 4 multiplied with 2.5 equals to 2 over s minus 2hs. So here is when you do the expansion already. So you'll be having 2 over s plus 4, then 2.5. I just rearrange to move the hs to the other side, like this one. 2 over s minus, is it minus or plus? So you have the 2 over the s minus 2hs, correct? Equals to a shs minus h0. So let me copy this one, very confusing. Okay. Next we'll be having 4s hs minus 4, this is 2.5, equals to 2 over the s minus 2hs. Then 4s hs plus 2hs equivalent to 2 over the s plus 10. So this one gives you 10. Factorize the hs, 4s plus 2. So this one will be 2 over the s plus 10. So hs equivalent to 2 over the s, 4s plus 2 plus 10 over 4s plus 2. Okay, so you can solve this by comparing the answer, direct conversion to the function of t using the list of equation. So you have something not simplified. The answer is not simplified yet. So you need to get the simplified answer. So it's 1 over s, 2s plus 1. 5 over 2s plus 1. Means you have to get the simplified fraction. These two, they are not in simplified fraction. You still can simplify further by dividing the whole thing by 2. So you will get the answer of this one, which we say this is the simplified fraction. Then you will be having 2s plus 1, and then outside is s. So you go to locate this using the Laplace table. Okay, Laplace table. So locate this one. So you will be having the one similar 2s plus 1 is this one. You can use this. So this is the hs. Finally ht. So this one I can use 5. 1 over 2, your tau is 2. 1 over 2 e negative t over 2. Okay, then the other term is 1 over the s multiplied with 1 over 2s plus 1. So you have the s outside. So this term 13. So you will get 1 minus e negative t over the 2, where your tau is also 2. Okay, then you can copy this answer into your solution. So this one cancel first. So this is okay. So this one you should modify as well. The answer is not start from 0. You should have this actually is ht minus 3. Okay, so you have to change to t minus 3 because event B start from t equals to 3. So you have to change to this and remove this. Okay. So simplify 1 minus e negative t over 2 plus 5 over the 2 is 2.5. Sorry, 5 over the 2 is 2.5, correct? E negative t over the 2. So plus 2.5, this is 1. So 2.5 minus 1 is 1.5. 1 plus 1.5 e negative t over the 2. So this one and this one, when you minus 1, it becomes 1.5. Okay, so this is your ht minus 3. Okay, so this is the exponential term. What you can do is always, you start from t equals to 3, the starting point, and also the end point, t equals to 33. So your ht minus 3 will be, and because the whole thing start from t minus 3, right? So your answer should be, just now you have t minus 3 here, right? So t minus 3, t minus 3, t minus 3, t minus 3. Just a little bit modification to indicate this event start from t minus 3. Because you already changed the function of t to function of t minus 3. So whatever inside have t, you should change to t minus 3. Okay, mapping. Okay, so from here, your ht minus 3 is 1 plus 1.5 e negative t minus 3 over 2. So when t is 3, then you're having 1 plus 1.5 e negative 3 minus 3 over 2. So you'll be getting 0 for this term. So the answer is 1. E0, 1. So 1.5, 1. Because E0, it is 1. So correct. So 2.5 feet. So when t equals to 33, repeat the same. Minus 3 over 2. So 1 plus 1.5 e negative 33 minus 3 over 2. So use your calculator. This will give you 0. Very big number. So the answer is 1. Okay, so you solve only using 2 points if the function is exponential. Okay, so you continue to plot this on the same graph. So you'll be having just now this one. So 2.5. So it will be a curve like this, where here also is 1, here is 2. So this is the function of ht minus 3. This is the function of ht. Then the endpoint is t equals to 33. Done. Okay, so this is the question where we do not have the transfer function. Then you have to use the initial condition to solve. Okay, so we will continue for question 2, simple question involving partial fraction. So I will have question 2 And then question 3 is heavy side. This one long. Then we will be having short question. Question 4, where I didn't manage to finish during the lecture slide, where you are using the S response. Okay, sub the S, go to 0. So this is just like ft when t goes to infinity. Final value. Using the final value theorem. Final value theorem, you need to focus on, for example, if you have 1 over s minus 1, s plus 2, s minus 3, example. If you have this s multiplied with the function of s, and you get the solution, okay, solution of the I call this one roots. So you will be having s equals to 1, s equals to minus 2, s equals to 3. Okay, if your solution is real number, like RE, is a S answer, larger or equals to 0, means it is positive number. 0 also, yes. Okay, if you having positive, start from 0, for the answer of this, like you have 1, -2, 3. So these two already larger than 0. It is a positive number. So if you have this solution, you cannot use the final value theorem. So you can go back to the lecture slides. So when you having the answer larger than 0 and making the term like you 1 divided by 0, something like this, it will give you infinite, means a very big value. So when you have this, when the time SFS cannot use final value theorem. So this is actually question 5. Okay, question 5. Some quick revision. I will go through again later. So the idea is the solution, when you have your S multiplied with this, the solution of this, any positive number, then straight away you cannot proceed using the final value theorem. What you can do is you have to Laplace transform the long solution. So the long solution to get this answer, then sub the t goes to infinity, finally to get the final value. So when the question asks you to get the final value or the steady state value, you always start from the S response, then you do the partial fraction, then you refer back to the Laplace table, inverse Laplace to get the function of t, and sub the t equals to infinity to get the final value. So what you always do is, you will start from function of s. So here maybe involve a lot of things like Heaviside, like partial fraction, okay? And then you have to inverse Laplace to get back everything function of t. So when you get this, here to here is actually long journey, involving a lot of maths. Then you sub your t goes to infinity, then this one only will give you the final value. This is a long journey from the fs to ft, and sub the t goes to infinity. Is a long way to go. Shortcut is when you have this, to solve final value, you don't need to do the inverse Laplace to get the ft. That's why it is final value theorem. Shortcut to get final value without getting ft, like partial fraction long solution, you can just S multiply with the Fs and sub the S go to 0. Then this is the final value already. So it is a shortcut. But there is a requirement. The requirement is, so you put here the requirement SFS, the answer of this cannot be S larger or equivalent to 0. If the answer of the S is larger or equals to 0, this condition cannot use final value theorem. So this is a revision, quick revision. So why we need to know how to use the final value theorem? It is because it is a shortcut without going through the long way of calculations to get the function of ft. With the fs given, straight away you multiply with the s and sub the s equals to 0. Then it will be the final value already without getting the function of t. With the function of s, multiply the whole thing with another s. So you have to multiply this one. Then sub the s goes to 0. This will be your final value. So we will cover this in question 5. So now we go to the simple question first, which is a question 2. Okay, so question 2. I will share this copy with you. So don't forget, all the handwritten notes will be only shared to Telegram. Okay, so please check your Telegram, the files there. So everything is there. So from here, a thermometer have a time constant. So as I mentioned in lecture slide, lecture 2, I say if 1 tau is given, then it is the first order. If 2 tau is given, then it is second order. Okay, so from here, tau is given as 0.2 and only 1 tau given in this question. So you'll be having a transfer function of output over the input equals to k over tau s plus 1, which is the transfer function, first order transfer function. So thermometer is placed in the temperature bath, and after the thermometer comes to equilibrium with the bath, the temperature of the bath is increased linearly with a rate of 1 degree per minute. Okay, so what is the difference between the indicated temperature and the bath temperature at T equals to 0.1 and T equals to 1? So here is your bath. Your thermometer is here. And fluid temperature, which means your bath temperature is X. Indicated thermometer, the thermometer reading it is Y. Okay, so at time equals to 0, this X is AT. It is a RAM input given in the question is 1T. It means when the system already in equilibrium, at T equals to 0, your YS will be equals to XS. Because you put your thermometer in the water bath, so steady state value, the thermometer reading must be the same as your water bath reading. So steady state, the thermometer reading must be the same value as the water bath reading. If not, then your thermometer is spoiled already. So from here, at T equals to 0, you start to apply a change to this water bath. Every 1 minute, you go to increase by 1 degree. The second 1 minute, then you go to increase another 1 degree, and so on. So this is actually the RAM input. As a function of T, it should be 1T. So if you change this to a function of S, then it will be 1 over S squared, which means you have Laplace of 1t. So it will give you 1 over s squared according to the list of equations here. So t, you will get 1 over s squared. So this is term number 3. So 1 over s squared. So ramp input means AT. So in this case, is per 1 minute, how many degree they increase? So it's 1. So if per 1 minute I increase by 5, then I have 5t. If per 1 minute I increase by 10, then it's 10t. So generally it is represented as BT or AT. So the A or B stand for per 1 unit of time. What is the change? Like this question is by 1 degree per minute. So you represent this as xt equals to 1t. When you change this to xs, then it will be 1 over s squared. Okay. And then remember this already in derivation form, where it is a first order, k not given, automatic it is 1, default, over tau s plus 1. So I put just this one, 1 over 0.2 s plus 1. So if we are using the transfer function, then everything will be already in derivation form. Means you already considered unsteady state minus steady state. So this is derivation form. So from here, they want you to find difference between indicated temperature, which is your Y, and the bath temperature, which is your X. So in this case, it is the value of, if you change everything to T response, it will be YT minus XT. So this is the question. They want you to find YT minus XT, the difference between the thermometer reading and the water bath reading. So in T response is YT minus XT. At T equals to two value, 0.1 and also 1. So we will do the first one. So in this case, XS is 1 over S squared. So this will be YS equivalent to 1 over 0.2 s plus 1 multiplied with. So this SS move to this side. Okay, to get SS over here. So 1 over s squared. And then this one will be 1 over s squared, 0.2 s plus 1. And you need to solve to get the simplest to get the simplest form using partial fraction. So you'll be getting repeating roots means a over s plus b over s squared plus c over 0.2 s plus 1. Okay, so here will be 1 over s squared 0.2 s plus 1. Then you will having all of this one multiplied to here, multiplied to here, multiplied to here. So 1 equivalent to a s 0.2 s plus 1 plus b 0.2 s plus 1 plus c s squared. Then you sub the s value so that you can cancel one of the terms. So the easiest one is s equals to 0. So how to make this term equivalent to 0? So it's 0.2 times something minus 1 equals to 0. So you use your calculator, you can propose the value of the s over here. So, or you can just put s equals to 1 or s equals to 2 to find the answer. So in this case, first one I put s equals 0, or you 0.2 times -5. Easy one, right? So 0.2 times -5, this will give you -1. So -1 plus 1 will give you 0. So s equals to -5. The other one, just put s equals to 1. Can be any value. But the easiest one is always to make the term to become 0. So in this case, when you sub all this one in, you will get your b equals to 1. C equals to 1 over 25. A equals to -0.2. So you copy the answer first. Later, you have a full solution. You solve using the partial fraction. So this one will give you the answer of, we always write the coefficient outside and then 1 over the s plus 1 over s squared plus 1 over 25, 1 over 0.2 s plus 1. Then this is the simplest fraction already, where you can straight away get your yt. So you can get your yt from the Laplace table. So this is simple one, -0.2. So s squared, 1 over s squared, you will get t. Then this one is, we have this one coefficient constant 1 over 25. Then this is the equivalent 1 over the tau e negative t over the tau. We have learned this just now in the previous question already, where your tau is 0.2. So negative chen t plus. So when you have 0.2 multiplied with 25, right? So it is just like 5 on the top. So 1 over the 5 is 0.2. Yes. So 0.2 e negative t over 0.2. So this is your yt. So now they want you to use this. So I will copy this solution. They ask you to find yt minus xt at t equals to 0.1 and t equals to 1. So sub yt minus xt. So what is your xt? Your xt is 1t, because it is a RAM input given in the question, RAM input. Okay, so will be, this whole thing is your yt. So it's sub to yt, and your xt is 1t. So negative 0.2 plus t plus 0.2 e negative t over the 0.2. So this one is your yt, and then minus xt, where your xt is 1t. So I will just put bracket here. So I put here is your xt. So xt minus yt minus xt. So in this case, we will be having plus 1t minus 1t, so gone. Okay, so we'll give you the answer of negative 0.2 plus 0.2 e negative t over 0.2. So you will factorize the 0.2 to get the simplest form. You will be having, so normally it's 1, negative outside, so 1 minus 0.2 e negative t over 0.2. So this one gone. I already factorize. Okay, e negative t over 0.2. Or you prefer to have 0.2, then -1 plus e negative t over 0.2, also okay. Both also same answer. So now yt equivalent to 0.1. So if I'm using this one, then with negative 0.2, 1 minus e negative 0.1 over 0.2. So use your calculator, you should get the answer of negative 0.079, and the unit they are using is degree Fahrenheit. So then yt equals to 1, then negative 0.2, 1 minus e negative t 是 e, okay, over 0.2. So this will give me 0.199 degree Fahrenheit. Okay, so you will see the tutorial, we start to put in numbers. So the long one is the heavy side. Before we go to the long one, I want to finish the short questions first. Then we go for a short break and we come back to solve the long heavy side together with the revision. So this one done already. Okay, if you cannot, you are not able to copy all, is fine. This one, as long as you understand, solution is given later, you can complete the full one later. So please put some important notes there. For example, RAM input 1t. S response become 1 over S squared. What is RAM input? Give other scenario. Every 1 unit of time, let's say I increase by 4, then my xt will be 4t. So this is a way more important than you actually busy copying the whole thing to get the answer. Put some notes there. What if the xt change to per 1 unit of time? The unit of time can be second, can be minute, can be hour. Maybe the change is 5. So you can put that. Now my xt become 5t. Then my xs become 5 over s squared. Rather than you memorize all this, you have to understand. The question can be changed. So we will cover the question 4 and 5 first. Then we move to the long solution for the last question, which is the heavy side. So we finish this one. This is the revision. We do some revision for your Laplace transform. So we will solve the A. So as a revision only. So ft is ut, where ut dimension here, unit step change. So what is unit step change? Step change is, if I put ut, it is 1. Then this is unit step change. If I put ut equals to a magnitude of m, a number, then I will be having my us equals to m over the s, right? So my us equals to 1 over the s. So if this is a number, then we call this as a step change. Some revision. So unit step change means m is 1. Okay, therefore you get 1 over the s. Step change, the unit is m. Can be a number changed to another number and remain at the new value. So this is a step change. Like you change the temperature of this room from 20 to 25 suddenly and remain constant at 25. So this is the change of 5 unit. So 5 over the s if you Laplace transform. So this is the one we call as a step change. When the magnitude is 1 for the step change, then we call this as a unit step change. So in this case, you will having your ut is 1, then your us is 1 over the s for unit step change where your m equivalent to 1. Magnitude is 1. Means the change is 1, like 20 to 21, 3 to 4, 7 to 8. So the change is by 1 unit. So now you are having all these questions with the u inside using this. Okay, so the one I bracket over here is just a revision. So this one is revision. Okay, now copy the question. Okay, I've moved to the bottom a bit. So your A, ft equals to 1 plus 2t plus 3t squared. So this is exactly the one you can get the direct conversion from the Laplace transform table. So your fs will be 1 over the s plus 2 over the s squared plus this one a little bit modification should be done. Need to sneeze. Okay. So you can refer back to the term 4. So I will copy the term 4 in here so that you can compare. So now this solve using term 4, where your term 4 is Laplace of t power to n minus 1. The answer will be n minus 1. Okay, then s power to n. So now you do some modification. I will be having my 3 outside. So I'll be having my 2 inside. So it's 3 minus 2. Sorry, 3 minus 1. Okay. This should give me 3t2, just like the original question given to me. Okay, so in this case, your n will be 3. Okay, so if I have this, I will be having the answer of 3 originally there, so don't touch. I just get the 3 there. So n equals to 3, 3 minus 1 factorial, and then s3. So it's 3 outside, then 2, then s3. So this is the answer. So I will get the answer of 6 over s power to 3. 6 over s power to 3. Okay. So I will group this one so that you understand. I just want to explain. They give you back the original value 3t squared. So this will be the answer. And you sub in here. Okay. So once you got this done already, just a revision of the Laplace transform. So this is A. Okay, B, ft equals to ut plus e negative 2t minus 2e negative t. So this is also direct conversion. When you get your fs, 1 over the s plus this one, e minus 2t is here, term 5. So you will get e minus 2t, Laplace transform of this, you will get this 1 over s plus 2. It's a term 5. Then you have the same one, negative 2e negative t. So it's using again the term 5. Negative 2 will be remain. So Laplace transform of this will get negative 2 outside, don't touch. Then e negative 1t. So 1 over s plus 1. So this is your conversion. So copy this and copy this using the same term, which is term 5. Then you will get the final answer of 1 over the s plus 1 over s plus 2 plus, negative 2 over s plus 1. So revision. So A and B just revision. C, I want to relate back to the one you have learned in Maths 2, which is the theorem 2. So for C, please focus. C, you will need to do some recap. When you see something like Laplace, T multiplied with E plus minus. I think last time we all can't remember. I think you use KT. So this is the one you have learned in your Maths 2, which is the theorem 2, where theorem 2 is your FT is T, means something, okay, something. Theorem 2 is something, function of T multiplied with E plus minus KT. So this is your theorem 2. Any function of T multiplied with exponential term. So this is your function theorem 2. So when you have this, the solution of this will be Fs. The answer will be F. Then you reverse the plus minus and then K. So this is theorem 2. So in short, your theorem 2 is, okay, I will put at the bottom here. So what is your theorem 2? As a recap, anything multiplied with exponential term plus minus KT. When you Laplace transform this, you will get the answer of F. Then S, reverse the sign, minus plus K. So you compare now, the question is Laplace of T multiplied with E. Now is the question of T E negative 1T. T E negative 1T. Okay, means you having a function of T multiplied with the exponential term. You will get the answer of F, S. This is minus, then become plus, and your K is 1. Theorem 2. So this theorem 2 means you have to get the function of S. So now your Ft is T, correct? Use your Laplace table, your Fs will be 1 over S squared. Means you'll be having 1 over S plus 1 power to 2 as your final answer. So today we do some recap. If let's say you have theorem 2, so what is theorem 2? Theorem 2 is when you have something multiplied with function, exponential function. So you will just get the answer like this. So example, your function of T is T. You should get Fs and then change the Fs to S plus 1. So this is like maths change to Fs plus 1. You will get this. The whole S, the whole thing, you replace with S plus 1. So this is the recap for C. The rest you do as usual. So I just solve the last term here. So this one, solve using theorem 2. And do some notes there. What is your theorem 2? So this is question 4 and the 5. Then we have a break. The 5 value. So based on 4A, they ask you to find initial and final value. So 4A is this one. So do some recap for initial value and final value. So just now we have solved this. Fs equals to 1 over the s plus 2 over s squared plus 6 over the s power to 3. Okay, now split into 2. Initial value and then final value. So s dot fs. This side also s multiplied with the fs. Initial value is when s go to infinity, when s go to 0. It's like the reverse of time. So when we say final value, time should be go to infinity, so the s should be the opposite, go to 0 for the final value. Okay, so s go to infinity, s go to 0. So when s go to 0 means it's a final value. It's a reverse of the time. When s is 0, t is infinity. When you put the t goes to infinity, means this is a steady state value. It's a final value, ultimate value. So from here, you'll be having this whole thing multiplied with the s. Something like this. So I don't put it there. The original question is like this. So I put equal to s multiplied with 1 over the s plus 2 over s squared plus 6 over s power 3. Same goes to here. Equivalent to s 1 over s plus 2 over s power to 2 plus 6 over s power to 3. So sub the s go to infinity. Okay, then you can solve. So from here, when s go to infinity, you will be having this one simplified first. Cancel. 1 plus 2 over s plus 6 over s power to 2. So this one will be the same. 1 plus 2 over the s plus 2. Okay, then sub s go to infinity. If this is infinity, this is infinity, you divide with a very big number, so this will give you 0, 0. So it's 1. So s go to 0. When this is a super small value, this is a super small value, it should give you infinity, infinity. So the answer is finally infinity. So this is the initial value. This is the final value. So if you pair with the t, it will be ft. For initial value is t goes to 0. ft, t goes to infinity. But now you can actually solve using this formula. Which this method requires the initial value theorem, and this method requires the final value theorem. Because from the s go to t is a long journey involving partial fraction, heaviside, everything. So if we want the shortcut to just get the final value and initial value, we can straight away multiply them with the s. So if it is an initial value, then we just sub the s go to infinity. If it's final value, we sub the s go to 0. So I have demonstrated how to solve using the initial and final value theorem. So we go for 5 minutes break, then we will solve the last question of today, together with a revision of heaviside long calculation. So make sure you go for a break, drink water, rest a while for a few minutes. So now attendance. Okay. Is it no line? Cannot repeat. Cannot. Refresh. Cannot refresh. Okay, never mind. I use my laptop. And now refresh. Let me try. Really helpful. Okay, so I will tap the code. Okay, so the code is N M X V S E. Okay. Okay, then we go for a short break. Then we come back. We solve the last question of the day, which is a every sign. Okay. Okay, the last one of today. Okay, so now what time? 1:24. Okay, so back. Okay, a thermometer having first order dynamics with time constant, again only one tau given, so it's K over tau S plus 1, is placed in the temperature bath at 100 degree Fahrenheit. After the thermometer reaches steady state, meaning that your thermometer will be having the value exactly the same like 100 degree Fahrenheit, follow the water bath temperature. And then the change happened. The water bath is changed from 100 degree Fahrenheit to a new value of 110. Okay, and then this change lasts for 1 minute, after which it is immediately returned to the bath at 100 degree Fahrenheit. So for example, I have water bath number 1, and I have water bath number 2. You only have one thermometer. Okay, this is thermometer. So when we draw, then everything becomes clearer, easier. So now I have a thermometer. Let's say we assume the same. The Y stands for the thermometer reading. Then the X stands for the water bath reading. So at T equals to 0, the water bath X during steady state. So I put X bar. I need to check what unit I put. Steady state value. Okay, X bar is fine. So X bar, or you prefer to put X at time equals to 0, it is 100 degree Fahrenheit. Same goes to your Y bar. It comes in equilibrium, means your Y0 should be also 100 degree Fahrenheit. So, or I can say this is actually the steady state value of the thermometer at time equals to 0. So if I put a note there, this is a steady state value of Y at T equals to 0. Same goes to this. This is the steady state value of, or I put initial. Water bath at T equals to 0. Okay. So now, when everything already in equilibrium, the water bath reading and the thermometer reading will be the same. So initially at T equals to 0, initial value for the water bath is 100, as well as the thermometer reading also 100. Okay, now a change is happened. So this water bath is placed suddenly in the second water bath, where the water bath temperature at that time is 110 degree Fahrenheit. Okay, so this is the water bath reading, which is your XT. And this only lasts for 1 minute. So for 1 minute. After 1 minute, it plays back to the first. So this one, after 1 minute, the thermometer, okay, the thermometer is placed back into its original water bath, which is 100 degree Fahrenheit. So 100 degree Fahrenheit, 110 degree Fahrenheit. So thermometer is being placed in second water bath just for 1 minute. And then immediately it is returned to the first water bath. So you can see there are two changes over here. One is it is placed in 110, and then it is placed back to 100. So 2 changes. So when it involves 2 changes and the changes are actually involving only number, like 100 to 110, 110 back to 100. So the change is actually heavy side. Heavy side. Heavy side doesn't mean it is a number lah. One heavy side it is actually function of t, like this one. Now the function of t here is actually a number 10. Why 10? Because you have to always consider unsteady state minus steady state. So last time I think Dr. Pang Ming have also guided you all or teach you all to put all these scenarios in the form of equations that we actually say you have the analytical equations to represent the whole scenario. So now you have the equation representing the water bath changes first, xt. So this is the water bath. So initially, t smaller than 0 means or equals to 0, it is during the first initial steady state. So this is the initial steady state. So meaning that you sub x0, then this one is x from t0 to 1, and this is x t larger than 1, or you put it here t0 to 1, t larger than 1. So during steady state, always you have to use unsteady state minus steady state. So at time equals to 0, your water bath have no time to respond yet. So the value will be exactly the same like the steady state value. Then steady state value is 100. So this gives you the change is 0. Why we need to consider the change? Because transfer function, you have to consider the change using unsteady state minus steady state. So all the values you are going to put will be the change with respect to steady state value. And then at time 0 to 1, the change is 110 minus steady state value. So unsteady state is 110. The water bath, I'm talking about the water bath. So water bath is 110, and then steady state value is 100. So this gives you the answer of 10. After 1 minute, you are having the water bath temperature as 100 again, and the steady state value remains 100 from the beginning. So all the steady state value the same, 100. Water bath, so SS state for steady state values of water bath, which is 100 degree Fahrenheit. So this will give you 0. So you simplify the whole thing to be 0, 10, 0. So you'll be having xt, the change here is 0, 10, 0, t smaller than 0, t in between 0 to 1, t larger than 1. So this indicates the change of water bath. 2 types of changes. You have to consider the steady state value because you need to minus. The transfer function is ys over xs equivalent to 1 over k is 1 by default. It is not mentioned in the question. Tau is 1, so s plus 1. So y is the output, x is the input. So when you have 2 changes, means you have to consider heavy side equation to solve. So from here, the question asks you calculate the thermometer reading at t equals to 0.5. So they actually want y 0.5 equivalent to what? So now you have to change this one ys, is here ss equals to 1 over s plus 1. What is ss? So how to solve ss over here? You have to utilize the prerequisite knowledge we have learned in Math 2 using the equation of inverse Laplace of E negative CS dot Fs equivalent to HT minus C dot FT minus C. Okay, so now we'll be having, last time you all learned, I don't know how they teach. Okay, never mind, I'll go through one more time. When the outcome is 0, you don't need to solve them because the value is 0. When you multiply everything with 0, it will give you the answer of 0. Hence, you only need to focus about this function, which is xt equals to 10. So xt equals to 10 from the time 0 to 1. So you have learned this in your maths. This means plus, this means minus. So you'll be having the equation that you start with h t minus the first one, 0, multiplied with ft. So this is 0. I just repeat whatever you have learned last time. Then here is minus. So the pattern is ht minus 1 multiplied with ft, where your ft is now xt, which is 10. So ht, or I put c1, c2. I think last time you all learned c1, c2. So the one at the left hand side is plus c1, and then c2 is negative. So from here is t minus 0, then your ft is 10 minus ht minus 1, your ft is 10. You have to compare with its original equation, ht minus c dot f t minus c. Okay, so we solve the first one first. This one, how to solve? Then you will compare. Now your c is 0. C is 0. Then your ft minus c is 10. So the equation always we start is ht minus the c1, then multiply with the function of t, just like now your function of t is it is 10. So the equation is ht minus c1 multiplied with ft, then minus ht minus c2 multiplied with ft. So this is the one you have learned in your maths 2. So then we solve the first part first, which is this one. We compare and get the answer c equals to 0 for this one. So you'll be having your ft minus 0 if you do the comparison. And this will give you 10. If you compare this one, equivalent to this one. So it's 10. So you change to f function of t, it will be still 10. Then the Laplace of this will give you 10 over the s. So this pattern will give you the answer of E negative CS dot Fs. So in this case, you will be getting C negative 0S dot 10 over the S. So, revision. Then you repeat the same for the second part. So second part is this one, negative. So I will solve this. In the next page, repeat everything again. Okay, this one. And this is compare with h t minus 1 multiplied with 10. And the negative is here. So your c is 1. Okay. You should compare with ht minus c dot ft minus c, because the answer of this will give you e negative cs dot fs, formula given to you. So now you have to change this one into this pattern with negative ht minus 1, where your c is 1, multiplied with 10, where your ft minus 1 is 10. Direct comparing both equations. Then your function of t, because this equation does not have t, so when you change the function of t minus 1 to function of t, if it is a number, it will give you a number. Okay, so just like this is 10. So if let's say your ft minus 1, it is t minus 1 over 5. When you have ft, you'll be having t over 5, example. So I will bracket this, example. But now, this part do not have t there, so there is no modification needed. Like Math 2, you have to do a lot of modification to actually get back the pattern exactly same with t minus 1. But this is simpler because the function of t does not involve any t in the equation. So when you change the function from t minus 1 to t, you will get back exactly the same value. So you will get your fx equals to 10 over the s. Then this part will be e negative 1s dot 10 over the s. Then you copy both side equation, ss will be the one just now, e negative 0s dot 10 over the s minus e negative 1s dot 10 over the s. This is your ss. Then only you can multiply this one into the equation of this one, equivalent to 1 over s plus 1 given to you, where your tau is 1, k is 1 given. So now you'll be multiplying this ss, which is all of this, to the other side. I will do it very slowly so that you can follow. Okay, so now your ss already moved to the right hand side. Then you'll be having ys equals to 1 over s plus 1, and this is your ss. You move it here. You're having 10 over the s. So I will keep originally one, e negative 0s dot 10 over the s plus e negative 1s dot 10 over the s. Okay, always compare with its inverse Laplace. E negative cs dot fs will give you the answer of h t minus c dot ft minus c. Now everything already in s response, you have to make the pattern similar to this one. For example, I'll be having 1 over s plus 1 e negative 0s dot 10 over the s, because I do the expansion. So I solve the first part. How to have this pattern, fulfill the pattern, look the same like this? Then you have to rearrange the position. You have e negative 0s, group everything you group together as your fs. So you'll be having 1 over s plus 1 multiplied with 10 over the s. So now, by comparison, what is your c? Your c is, by comparison, so this is just like e lag already? Oh, what happened? E. Hey, hand already? I have to restart my good note. Is it? Hey, is it my pen note? Oh, I know already, My cap is loosened. Okay. So this is E negative CS dot Fs. So this one is this. This whole thing is this. So you solve your C equals to 0 and your Fs equals to 1 over S plus 1 dot 10 over the S. So if you rearrange nicely, you have 10 1 over the S multiplied with 1 over S plus 1, which is exactly your term 13. So when you look at the term 13, it is 1 over the S tau S plus 1. So you will get this one, term 13, as your conversion. So this is just like 1 over the S tau S plus 1, where your tau equals to 1. Compare this. So you'll be having the answer of direct conversion of when you inverse Laplace. So your FT will be 10 outside, then bracket 1 minus E negative T over 1. Okay, so now you have to compare with its original, this one. When I draw, please follow. This one, you have to change to the pattern of this. Ft minus C. Okay. So Ft minus where your C is 0. So I just put 0. C is 0. Equivalent, because C is 0, so you do not touch anything. It will be 1 minus E. Then your T, supposingly, if you remember function, right, it will be T minus 0, the whole thing there. You just keep T minus 0 so that you understand. Now is Ft change to Ft minus C. So when you have the T symbol in your equation, the whole T should be replaced by T minus C. But in this case, your C is 0. But you just keep C here so that you understand it's actually from T to T minus C. So bracket. So you already get this term already. Then you also have this term because you have H T minus 0. Then the answer will be like this one. Later you have to inverse Laplace. So I will just solve to combine everything. Then I will be having my answer of the first part is H T minus C dot F T minus C. The first part will give me the answer of H T minus 0 multiplied with this one, 10, 1 minus E T minus 0, then done. So this is the first part. Okay, now we repeat the second part, which is the one, this one, multiplied with this. So I will repeat second time. So we move to the next page. So second part is 1 over S plus 1 multiplied with E negative 1S. Okay. E negative 1S dot 10 over the S. So you You always remember to apply the equation ht minus c dot ft minus c. The Laplace of this will give you the answer e negative cs dot fs. So now you are in S response, so you have to make the pattern to fulfill this pattern. So I will change to e negative cs dot fs to be e negative 1s dot the s, the rest of it you group together under fs, which means your fs will be 10 over the s multiplied with 1 over s plus 1. Then you can have the inverse Laplace of this equivalent to ht minus 1 dot ft minus 1, which is the answer of this one, where your c equals to 1. We are getting this one. We want to get this one. But before we get this one, this is ft minus 1. The whole thing here is your fs. The root map is to get ft, then to get ft minus 1, so that you can sub into this part. So we solve. Fs by comparison is 10 over the s dot 1 over s plus 1. You change to ft, you will get exactly the same answer just now. You'll be having 10 term 13. 10. And your tau is 1. And then you change the whole function of t to t minus c, where your c is 1. So you'll be having 10, 1 minus e negative, bracket the whole thing, t minus 1. Over the 1, don't need to write. So you already solved this part based on the answer of this one. Then you sub into this equation. You'll be having ht minus 1 dot, and then 10, 1 minus e negative, t minus 1, bracket. So you'll be having the final answer ht minus 1 dot 10, 1 minus e negative, t minus 1, bracket. So when you combine the two parts together, your yt now is the first one you have derived, which is this one. This is actually your yt. You copy this and combine them together, you'll be having ht minus 0 multiplied with 10, 1 minus e negative t minus 0, like this. Then minus second part, this is second part, so put it here, ht minus 1 multiplied with 10, 1 minus e negative t minus 1, like this. So this is your yt. Okay, now the question is, sub the t equals to 0.5 and also t equals to 2 into this equation. Okay, so I will copy the whole thing to the next page. Okay, so y 0.5, you have learned when t minus 0 means t equals to 0. This one t equals to 1. So when t equals to 0.5, you should relate to the one you have learned. You have 2 ht minus 0 and also ht minus 1. So at t equals to 0.5, this one not yet open. So it is 0 because this t equals to 1, this t equals to 0. So 0.5, this one, it is on. You have learned this, it should give you the answer of 1. When it is on, it is 1, which means your ht minus c will only have 2 outcomes. Either it is 0 or either it is 1. So this one is off, this one is on. So at time equals to 0.5, it not yet t equals to 1. Therefore, it is 0. So in this case, the equation you have, this one, you will sub ht minus 0 equals to 1 and ht minus 1 equals to 0 and t equals to 0.5 into the equation of this one. So how I sub? This one, the whole thing here, 1. And your t here, 0.5. Whole thing here, 0. Because at t equals to 0.5, this term is still off. Because this term only on. This is on when t is 1. Now t is 0.5, so still off. It is off when t equals to 0.5. Because this term only will be on when t is 1 minute. Meaning that anything below 1 minute, the term is still closed. So closed means the answer is 0. So means this whole thing will give you 0. So when you sub in, you will have 1 multiplied with 10, 1 minus e, negative 0.5. Okay, so the answer will give you 3.95. Okay, so repeat the same one. Now is this. The time now is changed to 2. Okay, so if t is 2, means this one still on, so it's 1. This one is on as well. And you sub this t equals to 2, this t equals to 2. So we'll be having 1 multiplied with 10, 1 minus e, negative 2, minus 1 multiplied with 10, bracket 1 minus e, negative 2 minus 1. And this will give you the answer of 2.3254. This is why you learn heaviside in Maths 2 and how you relate the heaviside you have learned to the scenario, where the scenario is pretty simple. Thermometer is being placed in the first water bath and then changed to the second water bath and put it back in the first water bath. So the change of this xt we call as the rectangular house. So you need to have the ideas how FT go to FS and how FS go to FT. What is your FT? Your FT is heaviside. So as a conclusion, what is your heaviside? Your heaviside FT ht minus c dot ft minus c. Your FS is e negative cs dot fs. You need to know how to go in this way and how can get back this. With this example, practice few times, you will feel better. You already learned the harder one in your math 2 already. We only pick the function of t, which is a number, to be applied in this module. So should be okay. So that's all for today. Thank you very much. So I will stop record. Okay. So the recording, everything is in here. So don't forget about the recording. The recording is always here, so you can refer to this recording. Everything is here. Okay. But the recordings won't be there forever lah, huh? So, and the handwritten notes is in here. I will share right after the class most of the time. But later I got class, so I will share maybe evening time. No, it's okay. I will share right after I finish the class. So you can go to your group. Where's your group? Control. Too many group already. So you can always go to here. Files. Everything is here. And the important information announcement I made last few days, already in recording, I think have 5 announcements regarding your test, your assignment, your practical. So next week, group 1 and group 2 will come for lab. Block E, ground floor at 9 o'clock. So for control module only. And for your MATLAB installation, this is the files I have shared in the Telegram. And then you only need to click these 2. By default, the Simulink is not click. So if you do not tick the Simulink, meaning that after you install everything, when the time I want to use, Simulink toolbox is not there. So if you can't remember whether you tick the Simulink or not, I suggest you just remove everything and then download again. So when the time they ask you which one you want, then you tick these 2, MATLAB and Simulink. Okay, that's all for today. Thank you very much.